Good. Okay, I'm back. I'm just going to adjust the camera to be the narrow lens version. It's a bit of the distortion. So we now have completed, which is a good thing. So start to put the frame together, which really forms the backbone of the build completely. So effectively, with this frame, this is the front, this is the back. It allows you to put two stacks on, so you could have, your FC here, or your ESC here, and your FC there. Now if you look at this, it doesn't matter; it's symmetrical both ways around. Obviously, if you've got a smaller stack, you can put the screws in for that. We are going with a 30mm stack today, so the two inner holes we will use with slightly longer screws that come with the flight controller. So you can see that these are around 30.5. There you go, diameter. So in the screw bag, they come with a number of different sizes of screws. You can see from the instructions. Maybe I ought to mirror flip this for you, then you could read them. Is that now going to give us the... Anyway, you've got a number of different size screws down this side. I don't know whether that makes it any better or makes it worse. Anyway, we'll crack on. So you can see that we have different types of standoff, different sizes, fairly clear. Some little tubes for the receiver antennas. We are not going to be using those. Some slightly longer screws that could be used for the flight control stack, which we'll see how we get on with those. And I'll give you a measurement of those in a second with the micrometer. And as we said, a number of small standoffs and a number of larger standoffs. We'll see how they come into play later on. So, looking at putting the frame together then, I tend to make sure that the pointy end points forward or points back, so points outwards from the frame. Effectively, we're going to go on like this, with the top on like that. And what I'm going to do is just put the outside screws on first, and then we'll then come back to the flight control stack in a minute. But if you can see where that is, we'll just quickly measure that to ensure that we get the right size screw. So all the way through, that's about 11mm. So I know from the instructions that the closest they have to 11mm is 12. So we'll just quickly dig out the 12s. That looks about 12. Yeah, sure enough. So that's one of those, two of those, three of those, and one more to make four of those. As I said, when we get to the flight stack, probably going to go with a slightly longer screw through the middle for the flight stack. So we will get the flight stack out as the next bit, but just get these four outer screws into the arms first, get it all sort of held together, and then we'll work our way through the 30mm, 30.5, I should say, inner screws. Now, slight change format, so it's got a bit of Loctite on, so again, don't need to worry about Loctite, which is rather nice. Do like these builds that come with Loctited screws, and the press nuts already in. Don't do these up rock solid. Do them so they're just, you can move it, but not much. I've found that working in pairs like this, again, just making sure that you've got the outer pointy bit pointing out. So that's two of the arms done very nicely. Number three, remember we're looking for the pointy bit to go out on these. So hopefully everybody can hear me. I'll just share the stream in a second. Now, unfortunately, what that means with them being 12mm is you can see that there's actually a millimeter that points up over the top, which I don't like. I do have these little caps that I've made that we will be able to put these caps on later, but we'll have to put a hex screw on top and fix that in place to put these on. Normally, when you get the press nuts, which have the slightly one side that's slightly proud of the carbon fiber, it allows you to make use of those tops of those press nuts to put on those little caps, and then that means you've got no wire able to wear away on the screw itself. Whereas here you've got about 1mm of this 12mm bolt pointing through. Now, I guess the other option is to put a 1mm washer on the other side, and that would enable us to quite easily lose that little bit on top. But as I say, it's quite annoying, it's quite rough, and I do want to fix that. Okay, so that's the forearms on. Okay, and you can see they all look quite nice. Now, the next bit then really is the flight controller, which is the Mamba F722 app version. Now, there's a number of little bits we're going to have to think about soldering in a minute, but if we work out our way with the screws to start with and then come back to the soldering elements, tend to keep everything in the box. It does come with some nice screws that are already ready to go. The challenge is to make sure that the difference between these two screws and these 4 screws and those 4 screws, maybe we'll need the extra height because of the thickness of the frame. As we know, that's 11. So by the time you've taken 11mm off of these, you've got about that much left. With the nice thing with these is they come with these nice little silicone O-rings that isolate the FC from the carbon plate at the bottom. Yeah, and these ones are 24, so 11mm off of that, and you're going to be left with 13mm to go through the stack. And typically speaking, yeah, it's very much there. So probably worth actually putting in the screws that came with the flight stack rather than the suggested ones from the kit itself. So we'll just work through that. We've then got the power lead to do. Just letting the guys know I'm building. So good enough. Leaving those other screws loose to start with does help you then when you have to come to push these all the way through. Of course, on the other side you've got the press nut, so it will sort of stop. But we know that we need about 13mm on the other side, and it should be just about enough. We're going to try just one, just to see how we get on. In fact, I'll probably put 2 through. The reason for not going for more than one is that they are a pain in the backside to screw in. So if you put one in, you can just try it for size. And remember that the front and the back to this. I also didn't talk about the camera, which we'll talk about when I get there. It's a real nice camera, and you can see yeah, you can see, pull off the rings at the bottom. I really do like this. There is a choice you could mount it that way. Now the problem being screwing it on, because it would screw on, is that everybody who builds already will know this, is of course then your arms will only have one screw. So it would have been interesting if they put another one in there, but yeah, so just find the right one to take out actually. So here we go. Let's push. Now the arrows pointing forward, so we just push that screw out. Now we want to put a couple of these on. I'm going to take off these ones as well, just for now, and push them up. Push them up for, probably going to put just a couple of rings on this at this lower level. We do have enough. That's the really nice thing about Mamba. They really do think about your build when they provide you with all the bits. So I'm just putting 2 back on and then moving the screw back up. So we're sort of simulating the height of where the stack would be. And I'm just going to take one off this side. I've already got this one set up, as you can see, with the 2 on there. So here we go. So the question is, once it's in position, will I have enough room to put the screw on? Now the answer to that is yes, but not much. Yeah, I need to find that in a minute. I like these little plastic cap screws. I probably dropped it on the floor. I'll have a look for that in a second. So although it does seem to work quite well, it's not quite enough, which is a real shame. So what we'll do now is we'll try it with these longer screws and see where we get to. That's obviously going to give a lot more, but maybe you can put 3 on the bottom as you know, possibly they've designed it to be. So yeah, let's do that. At the same time, I'll try and find 1, 2, 3, 4. Yeah, okay, so just take out. Okay, it's a pain when you've got to unpack these out. Here we go. So we've now got the slightly longer screw. So these are 30. So 30 minus 11 is 19. We needed 13. So 13, 14. So we're going to have 5 mil left over. Now, there's some nice little carbon plates that I have that I can stick on top that potentially, you know, we put a cover plate on top of the ESC, which is maybe a nice way to do it, but we can see. What's beeping in my ear? Okay, so we're going to do the same test we did, except now on the bottom of these, I'm going to push back through so I can get 3 on, so that we can do a simulation of 3 rubber rings. And this will allow us just to test whether there's enough space in there. And yeah, that's pretty good. I've got 1 over on this side to do. Push through, get 3. So remember, I had 19 on this side now. So obviously 19. Yeah, you can see we could have probably done with somewhere in between. There you go. So there's going to be plenty of room now for us to go with that. Yeah, so 4 of those and then cap off the top. That should be fine. I might even put a rubber ring on the top as well. Okay, so do be aware on these Mamba stacks that they go for another rubber ring between that and the standoff. So right, okay, let's put the 4 sorry, 3 remaining. I've done 1 already. I do like my little woe stick driver for this. It just makes it a little bit easier. Make sure I get the correct pack. Yeah, there we go. You've got to remember which way to take these out. Clearly got it wrong. Just make sure it's the right one. Yeah, it is. Also provides the final tightening of the arm as well. They're a little bit stiff just to get through that first bit, so probably just hand torque it through there. Do occasionally put these bits into my drill. It's kind of like a sledgehammer to crack a nut. And once we've got this in place, we're probably going to just take off the top flight controller anyway to solder the leads. You'll see I sometimes even just take the stack off. It doesn't do any harm. So all I'm doing is just going around these now, opposite corners, just to cinch them up tight. Pretty much there. And it's enough firmness to feel your hand start to slip, but not too much more. And now you can cinch up again diagonally the remaining arms, and that should put us in a good place. Having all the arms in place. Okay, so we said 3, didn't we? So it's 1, 2, 3 on the first. And don't worry if you run out here. There's enough within the bottom of the stack as well. So probably do one more with what we've got down here. The other thing to check is that with the standoffs on, and I know it's the 4 smaller ones, that there is enough room. Now that actually is looking pretty goddamn close. So yeah, it's pretty much, there is probably a millimetre to spare between that and the top of the frame. So ideally we'd need something in the middle of that 24mm to that 30mm to be the right length. So probably something in the order of 27mm would be where we'd want to be, which sort of seems like a magic number. It's just a bit disappointing that just about at the top. Again, a washer on the bottom could help that. And I do like the Impulse RC cup washers that they provide with their frames. Something like that would work well. Of course, the only downside of having bolts through the flight controller is that when you need to change an arm, you do need to at least undo one bolt for the side frame, and you can see it was a long way in, so it does take time to do that. So I now just simply pull off the remaining washers and push out these screws. Remember that there's another washer on the other side of this. You can unplug this quite easily, so that's what I'm going to do. There's a huge debate over whether you have these motor pads on the inside or the motor pads, the battery lead here. I'm going to go with the battery lead here. Now it does look like I could probably solder it in place, so we'll see how we get on with that. And remember when we took this off, there was one rubber ring, over the thread. So I'm going to move away from the standard wire gauge that they gave us in the kit. Well, it's 14, SW14. I'm going to 16 anyway. You'll see in a second. It's a bit thinner, and with these short wire lengths, it matters not. And if you look at the ones that you actually have on your battery packs, probably most of them are probably this thicker wire, but it really doesn't matter. And one of the really nice things here is they've also got 2 points for a capacitor too, and looking through the gap there, that would almost fit the capacitor in there. So maybe there's something I can do around fitting that capacitor in there. We'll see. Maybe that's a job for part 4. Okay, so as I said, I'd be looking to use slightly thinner standard wire gauge. Now, I'm going to go with the length that they've already got, I think. If we have a look, I want the wire to be probably around there. So in fact, if we cut about there for now, we can always trim these down. Now's the time to make sure you've got the opposite XT60, so that when we solder the XT60, we solder it the right way. Also, the other good point to note is make sure you note positive and negative. We're actually going to mark the negative so it stands out. It's very easy with these to get confused on the XT60 connectors. Right, just a quick swig of my tea. Okay, so we'll tin these up in a second. I'm switching on my slightly bigger soldering iron rather than the. I've got a TS100 to do most of the joints, but we're going to work with a Nantex soldering iron 660 TC. A little bit more meat in the actual solder tip itself. I'll show you that. There you go. So it allows us to be able to conduct a little bit more heat into the joint, whereas this is very much a surgical TS100, beautiful soldering iron, but probably a little bit too thick for what we're doing. Okay, so I'm just checking now how deep these need to be in. Probably need to get a black and a red bit of wire as well for the capacitor. We'll do that in a second. We'll just work this out first. So I kind of know how much I've got to take off. Soldering really close. So tin up those 2 wires. If you do find you've cut them slightly too long, it isn't too much of a hassle. Just want to switch this on. No, I hadn't, so I have to just wait for that to warm up. You can now see that these will feed nicely into the solder pads on the ESC, and that'll be the next job. Shouldn't take us too long to run round, and then we're into the final stages of assembly, which is the VTX top plate and the camera and the receiver. So come on, soldering iron, heat yourself up. Apologise for the rattling. You do find if you've got a little bit of excess wire hanging around after you've done the soldering and you're worried about shorting out, you can get some liquid insulation tape, and that's a really good way of insulating the power cables from the ESC if you don't feel happy with your soldering. A good reason for doing the wires first as well is that it gives you a little bit of time to practice as well, which is always useful. We're going to tin those up. You can see that the iron's tinning quite nicely. I'm sorry, I'm just out of shot here. I'll move this back in. The wire is tinning up quite nicely. I'm going to move the frame out of the way just so we don't splash on the frame while we're doing these. I'll bring the frame back in a second. Yeah, it's not quite hot enough. Still waiting for it to warm fully up, but give it a go anyway. You don't want to put too much solder on this because it has a habit of wicking back up the wire, and then it makes the wires very stiff. So just watch where you are with it. And again, I go with a hotter iron with a shorter time rather than the other way around. The other thing you probably could do, although it's worth measuring up, just to double check we're not too long. Put a bit of stress relief on the wire. Yeah, it's about the right length. So quite happy now to put the XT60 on. And as we said, that there's a trick for doing the XT60 where we need to mark up. I need to find my little marker. We need to mark up the, I'll probably use a pencil, unfortunately, because I can't seem to find my Sharpie. But on the XT60 itself, you can see there's a positive and a negative, and they're not always that obvious. So we want to make sure that when we sort of put this together, that we've understood exactly where the negative is and marked it. So I'm going to mark this side. The other thing you need to do is to make sure you haven't forgotten to put the little cap. So I've made a little mark on the negative side, and we've got the solder cap, and that's going to clip on. So to do this again, I'm going to trim up the other end of the wire this time and prepare that for soldering into the XT60. I do put a little bit of extra, strip it back a little bit further. Two reasons for that. One, you can tell which way it was round if you looking, because obviously you don't want the longer wire going into the shorter gap on the ESC, 4-in-1 ESC. You want it to be available, but also the solder buckets on the XT60 are slightly longer, and it enables you just to get the right amount of solder into the XT60. So that's the positive done. Now just solder up the negative. And the trick with soldering, if you've not done much before, is to make sure your iron's hot enough. You've got a good quality solder. I've got a lead solder. For the amount of time that you use it, it's not really having an impact on the environment. If you're a manufacturer, then you absolutely do need to make sure you're following. But we're hobbyists, so rules are slightly different for us. You can see that when I offer it up, it fits quite well. And what we're going to do is just make sure there's enough solder in the bucket now. The aim with all of these joints is to get solder in both sides of the joint, and then joining them together is just a matter of tinning the iron, which we call wetting, and then joining the two together, and fairly straightforward. I am going to add just a little bit extra to the joint itself. It looked a little bit dry. Okay, enough on the soldering iron still. You will find that it does wick up the solder very quickly. Okay, you can see that end's on. Now, I haven't got to worry too much about the cap because the other end's open. But of course, I do need to put it on before I solder it onto the flight control, onto the ESC. So again, just making sure we're soldering into the bucket. There we go. Good amount. And just making sure that the iron is tinned. And then what we're going to do, join the two together. This one's being a little bit, get quite enough solder on my iron. And there we go. So both joints are now complete. So what we're going to do now is just put the little cap over the back of this. And it clips on with a little clip. Pull it apart, and you can see that I've got a negative where the negative is, and obviously positive on the positive side. So it's always used to have one of these just to hold those pins stationary while you're soldering them too. Okay, so we've got to do the same trick now on the joints at this end. And the trick that we're talking about here is to solder both ends first and then tin the iron, which we call wetting, and then apply the iron to the joint to join the two components together. So let's just work that through. And work that through. (25°C), and I know that'll make a lot of you. But the great thing about that is it's a quick on and off that you're after here. So the solder, we've already pre-tinned the positive lead, and all we're going to do now is join the two together by applying heat. And there we go. It's as quick as that. And do the same for the negative lead now. So literally put it in the place, and there you go. So now we've got the battery lead on. Okay. You can see that that will twist around nicely, attaching to the strap and be in the right place for the battery. What we're going to do next, and it's good to leave the flight controller stack off for this, is to do the, I'm going to turn off the heavy soldering iron now, is to do the motor leads. There's 4 sets to do, shouldn't take too long. We'll follow the same process for each one. Hopefully I can get you closer to the action by moving this across here. Yeah, that'll do. So I'm going to swap soldering irons. We're going from the Antex, which had this really thick cap, to using this TS100 that has this thin. But again, we're going to use the same 400 degrees on the tip. Now, we're going to make sure that the wires, as they come from the motor, are thread through the prop stripe protector and through the cable guides, cable clips, I'm calling those, into this. Now, you want to make sure that they're not overly tight. So I just put them where around the middle before we cut them. And you can see it's about there. So that's a nice little. And if you're unsure, you can always go back and just remeasure. Make sure you've got enough room. You can see about that much. So if you have a look, about that much. And you will cut to that position. So here we go. Straight cut. Fortunately, my bloody clippers are not great. So, and we'll use, again, being slightly blunt when you're stripping them is not a bad thing, but yeah, you'll see. So you can see we've got a couple of methods then of doing this. We can go around and do one at a time, or you can go around and tin them all. So I'm probably going to go around and tin them all now because it's easier. And then we'll come back and do each wire set as a pair, as a threesome. So just make sure your soldering iron's at 400, which I know mine is. Again, making sure that the soldering iron, you tin or wet it, whichever term you prefer. And you can go off. If I just do this side, and we can swap and do the other side when we're ready. These do take a bit of heat, so slightly longer than we had on the power connectors at the back. Although the earth, the black lead at the back, does have a lot more metal involved in the pre-CB, and therefore does take a little bit of time to heat. The beauty of having a hot soldering iron is that that's very straightforward to deal with. If you've got enough heat in the soldering iron, and the joint is clean, the solder does deposit very quickly, as you saw. Right, so we're just stripping these back about the width of the pad. You want to be careful here that when you tin these leads up, you don't tin them over the board. And we'll also check them to see that they're the right size. And remember, I left a little bit free, so that would be okay. And there we go. All 3 are tinned. My desk has come a bit untidy, so I'm just going to move some of these bits out of the way. The nice thing about the Emax motors is they come with a really good selection of screws. As I say, we've not used those screws for the good reasons we talked about earlier, i.e. the TPU soft mounts. Let's just move those out of the way for now. Okay, so now I'm going to check each one of these in turn. Now, some people like to use long nose pliers to hold these in place, and you can see that they're just about spot on. So we can do that. I'll show you that technique. If you're quick on and quick off, you can get away with just holding your finger there. But again, it's important about having the right temperature soldering iron, having tinned both bits, and then wetting your soldering iron. And the job is done. And that was probably slightly too long. Just cutting that back to size. And we'll do the same with the next joint. So you've already tinned the wire, you've tinned the pad. So now all we've got to do is wet the soldering iron. Once we've got enough solder on there, holding this in place. The heat to go through. And there we go. Job done on number 2. And finally, number 3. And as you can see, these screws here are sticking out. So I'm going to make sure that my little cable clip is very close to that. And my plan for sorting this out is to put a little nut over the top of that, and then we can stick these little caps over the top, and that'll quite nicely finish off the quad. Or if you're not that bothered, then you don't have to use that. You can just leave them. Okay, so here we go again. The final one, making sure you've wetted the iron. Not too much solder, so you just need to be sure. We'll put too much on there. That particular one was a little extra heat needed through, but as you can see, it's now done. Apologise for all these screws getting in the way. Okay, so whilst you do need to keep the instruction cards really useful. Again, Mamba are particularly good at providing really good quality. They also have online manuals as well, which really helps. So again, we're now looking at the next set of wires. Again, measuring them around the middle solder pad is my recommendation. Also, as we said, making sure there's a little bit of freedom there so that the cable isn't tight. And you can see we're about there. So I'll cut those to size. And the next job is to strip and tin, which is what we'll do. So there you go, 3 stripped. Do make sure there are no loose wires hanging around single strands, because if they then solder between your pads, you'll find that your motors won't spin very well, but it'll also mean that obviously when you come to set up the quad, and if you don't go through a proper test to check your motors are spinning before you fly, you may find out that you think one of your motors is dead, and actually what it is there's a small piece of wire bridging between the 2 pads. And again, what we're going to do here is again matching, the wires come all the way through the prop strike protection, through this cable clip, and then to the pad in the same order. So you're looking just to repeat that same order. And again, making sure we wet the soldering iron, constrained with the space. You can always take off the nut and the washer. Once you've had a bit of practice with these, probably actually I've made these slightly too long. You can come back and neaten these up. I probably won't bore you with doing that, but if we do break for the next one, right, and you can see there I didn't quite have enough solder on. And number 3 is ready to go. As we said before, if you're not quick enough, you do tend to end up burning your finger. Wasn't quite there with that one, but it wasn't as cold as the others were. Okay, so you can see here I've made probably these 2 inner wires slightly too long. I'm not going to bore you with redoing them now, but you can kind of, maybe you can't see actually, you can see these ones here are slightly longer than the ones on this side. So we're flipping it around now. I'll tin the pads first, and then we'll cut the wires to length and tin them, strip and tin, and join them. Coming up on the 40 minutes, so I will probably stop at that point. So again, making sure your soldering iron's nice and hot, tinned before you tap the pad, and then you feed the solder in to the edge of the soldering iron, and it'll flow across the whole of the pad. The nice thing with the solder we're using is got a resin core to it, so the resin acts as a flux, which makes cleans the joint effectively. As you heat it up, it actually removes the oxide from the joint and allows you to make a clean joint. Flux multi-core solder is really useful. We normally have 5 cores of flux in this type of solder, and 60-40-ish tin lead solder. Okay, so again, we're going to try and do it a little bit better this time. Lining up the cable clip with that portion there, I'm going to make sure the wires come round, and then I'm going to make sure that we bend them where we want them and cut across. This time I am going to make sure I do take into account just double check. Yeah, the other one's slightly too long still. I'll just take a little bit off that. You can wait till you do the stripping and remove it, but that doesn't really deeply matter. Probably okay. Right, so again, strip, tin, and then we'll make the joints. Just making sure, as we said earlier, you're twisting off any little hair wires that, any of the strands that come out. When you're soldering these, you're not soldering it over the board. You don't want little bits of solder on the board. And this gets most of the heavy soldering out the way, and then we're focused purely on getting to a point where we can solder on the receivers and the transmitters and go from there. So again, just making sure, I'm 400 degrees, see that? I'm going to tin or wet the soldering iron. Again, you can And again, being quick enough, you can get away with soldering these. And again, I probably shouldn't have shortened that. You know, I took an extra bit off that. It's now tight compared to the other two. And yeah, that's not the best thing. So again, just making sure I've tinned this, not too much, but enough. And then there we go. So again, adjusting the cable clip to around where the screw is. Doesn't have to 100% be there, but it's a good place to be. It also gives the wires a little bit of protection too, which is what I like. We are now going to make sure, again, I'm going to make a mark with my nails at the back. Yeah. And we'll cut across. Again, taking into account, definitely do need a new pair of clippers. These are bloody awful. And yeah, there's Chris just calling me. There's going to be a Quadaholics live stream on RC Dad's RC Hangar's channel very shortly. So yeah, I've definitely decided I'm ordering a new pair of cutters after this, side cutters. Okay, so again, we're soldering at the end. Make sure you do get coverage all the way around. Don't solder over the board. Do make sure you put enough on, not too long, otherwise you make the wires very stiff. Set, very good. Probably the M1 there is slightly too long. So we'll just chop off the end. Okay, and again, going to go from this end back. I mean, in the past, we'd have had ESCs on the arms, and we'd have had double the amount of soldering to do. Well, treble actually the amount, because you needed to provide a link to the motor to the ESC, and then the ESC to the flight controller, and then power as well. And you know, that required 6 sets of these solder joints that I'm doing now. So you know, it's great to see these days that these 4-in-1s, as they become more reliable, become the de facto way of building a quad. It's much faster, which is great news for everybody. So I'm probably going to bring the live stream to a halt at that point. You can see now I've soldered all motors to the ESC 4-in-1. I've got on my power lead ready, my XT60, so you can see that you know, fits nicely round without too much hassle. And I've got my 4 motors mounted, and in the next one I do, we'll go on to mount the VTX and the camera. We'll talk about the camera. Got quite a nice special camera. It's a Runcam Mr. Steel edition. It is a really nice camera. Talking about probably Cmos and Ccd. You know, you'll have heard people talking about CCD. It's just like a normal standard shutter on a normal camera. One shut, you know, one capture for all pixels on the sensor. When you get to a Cmos, it sort of does a running shutter, so i.e. it's running for each pixel in turn, reading the value. Now, the advantage of Cmos is cheaper to make. CCD are normally seen in high-end cameras, but it does have a tendency to have greater noise, and especially in low light. So Cmos cheaper, but does give you a better performance. So, you know, these days, and not, but anyway, but we are where we are. So that brings me to the end of part 2.